Okay, so in lecture 3, we're going to cover rational expressions. Basically, you have polynomial expression divided one. So what we're going to learn today is try to learn how to reduce rational expressions to the lowest terms. So whatever we learned in the last lecture will be very helpful for lecture 3. Now, if you have rational expression, you can do multiplication, you can do addition, subtraction, multiplication, and division there as well. And then of course at the end we're going to simplify complex rational expressions. Okay, so rational expressions. So rational expression is the expression of the form. So rational expressions is an expression of the form capital A over capital B, where A and B are polynomial expressions. Because rational expression in a way is a fractions, right? So we need to impose one very important condition is that the denominator cannot be zero. So in this case, B is different from 0. All right, so that's the definition of rational expressions. Now, the next thing that we want to cover is how to reduce the rational expressions. Okay, so if I have this reduction property, or if I have this calculations, A over B times B over C. Okay. So you can do cancellation like this. You cross out the B and you're left with A over C. But in order to do this again, because we are dealing with fractions, right? We need to impose condition in the denominator. That is, B is different from 0 and C is different from 0. All right, example 1, can you reduce this expression to the lowest terms? All right. So to reduce this rational expressions, the first thing you do is you factor the numerator and the denominator. You okay with that? So what is the factor form of the numerator? Again, you're looking for two numbers such that when you add them together, you get positive 4. When you multiply them together, again, you get 4. That's for the numerator. So what do you get? 2 plus 2. So the numerator is x plus 2 times x plus 2 divided by the denominator. So what are the factors? Plus 1 and plus 2. So I get x plus 1, x plus 2. Okay. Now you have x plus 2 on the numerator, x plus 2 in the denominator. And in between of x plus 2, there's multiplications. Not addition, not subtraction. Multiplication. Therefore, you can cross out x plus 2 in this case. And you're left with x plus 2 divided by x plus 1. Again, fractions impose conditions. Okay, so in this case, I'm going to impose that x plus 2 is different from 0 or x is different from -2. Then x plus 1 is different from 0 or x is different from -1. Yes. 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 So I'm looking for this answer as well, because later on, of course, we're going to learn something called rational functions. Okay. Then when you find the domain, right? So the area on which the function makes sense, domain, right? We need to find this, what is it called? Difference as well. Right. So we need to find this condition eventually. So it's good to build up the technique at this point. Okay. Any question on example 1? Okay. That's a very good point. Like you have to find this condition before you make the cancellation. You don't wait until the end to find. You find the condition at this step. That does that make any difference? That's going to make a huge difference when you get to rational function. You will see that you need to find the these conditions before you making any cancellations. Right. Example 2, again, you factor the numerator and the denominator before you make any cancellations. So on numerator, the common factor is 2, right? So you left with 2 times 4 minus x. What about the denominator? So what are the factors? -4 and 3. So x minus 4 times x plus 3. You notice you have 4 minus x on the numerator and x minus 4 in the denominator. So let's swap the 4 minus x to x minus 4. Do that. You take our negative sign on the numerator. You'll finish the step. So x minus 4 on the numerator, x minus 4 in the denominator. You can cancel them out because there's multiplication. Okay. So x minus 4, x minus 4. Again, you impose the condition that x minus 4 is different from 0 or x is different from -4. And x plus 3 different from 0 or x is different from -3. I'm sorry, here is +4, not -4. And you're left with -2 over x plus 3. So for multiplications, if you have A over B times C over D. If you have two rational expressions multiplied together, then you just multiply the numerators together and the denominators together. And you should get A times C divided by B times D. Again, because we are dealing with fractions or rational expression, the denominator cannot be equal to 0. So we impose the conditions that B is different from 0 and D is different from 0. For divisions of rational expressions, you do A over B divided by C over D. When you divide fractions, you can rewrite it as multiplication of the reciprocal. So A over B times the reciprocal, and you get D over C. And then from here, you can just do multiplications, right? So the top multiply together, the bottoms multiply together. So AD divided by BC. Now for division, it's a little bit tricky when you impose the conditions. So let's take a look at the fractions that we have. You have one fractions, another fractions, and the fractions right here, okay? So B has to be different from 0, D has to be different from 0. You okay with that? And then when because of this division, you multiply by the reciprocal. Now you have the third condition, that is C has to be different from 0 as well. Here, you impose that B different from 0, C different from 0, and D is different from 0. For canceling again, well, I have mentioned this point earlier that you have to find the conditions before making any cancellations. Okay. Find the conditions. Of the denominators. Before making any cancellations. Now for the procedure, when you want to multiply two rational expressions together or divide two rational expressions, you can follow these steps, right? So I assume that I make assumptions that nobody has seen this material before, therefore this procedure, okay? But if you have done this material before, you familiar with the process, your own process, just follow your own process, okay? So this step adjusts my assumptions that nobody has seen this. You good with me? If you've done this before, if it works for you, just follow your lead. Okay. Okay. But let me go over this step a little bit. So the first step, when you have the rational expressions, factor the numerator and the denominator when possible. Okay. Then cancel all the common factors. And then multiply the numerators together and denominators together. And if you have the divisions of rational expression, you multiply the reciprocal. Okay. All right, so let's start with example 3 and see what happens. Given these expressions, we're going to do a simple simplifications that just find the common factor on the numerator. So here's what you get. So x is the common factor on the numerator. You have x minus 2. And 3 is the common factor in the denominator. So x minus 2. So you have 3 is different from 0, obviously. we impose the condition that x minus 2 is different from 0. So this implies that x is different from positive 2, and then you can make the cancellations, and you get x over 3. Any questions on A? Good, straightforward, yes. I remember the 1/3 x. No, it's totally fine. So if you write like this, it's totally fine, it's the same. Right, move on to B. Now it's really the rational expression by one another. Right. So factors the numerator and denominator when possible. So let me start with by this problem by factoring. Right, so x squared plus 5x minus 6 can be factored into x plus 3 sorry, x plus 6, x minus 2 divided by 12x. Now you multiply by the reciprocal. Impose some conditions here. So x has to be different from 0. Okay. Here again, x is different from 0, so it's just maybe 1 x different from 0. And then in the denominator, you have x plus 6 different from 0 and x minus 1 different from 0. So x different from 0, x plus 6 different from 0 implies x different from negative 6, x minus 1 different from 0, x different from positive 1. Now simplify. So 12 and 4 cancel out. So this is 1 times, this is 3 times. The x cancel out. Then that's it. Nothing else. You'll have it on the numerator is 3 times x minus 2. And in the denominator, you have x plus 6 times x minus 1. Question? If you don't have any questions, let me move on. Am I moving too fast? Good. Right, in the next example, it's the same thing. Right, you have divisions of rational expressions. So factor when possible. So I have x plus 3 divided by x minus 2 times x plus 2. All together divided by x minus 3 times x plus 3 over x minus 2 times x minus 2. Now rewrite this. Right. Divide a fraction, that means you can multiply by the reciprocal. So you have x plus 3 divided by x minus 2 times x plus 2 times x minus 2 over x minus 4 times x plus 3. conditions. So here you have one denominator, x minus 2x plus 2, zero. Another denominator, x minus 2x minus 2, and that becomes 0. Good. Then one more denominator, so x minus 4 different from 0x plus 3. Yeah. So there are quite a few terms here. So let me start with the top. So x minus 2x plus 2. So x minus 2 different from 0, x plus 2 different from 0. Okay. Then move on to this denominator, x minus 2, x minus 2, but we already have this x minus 2, so we good. Okay. I have a question? Okay. So if you already see x minus 2 or any term different from 0 previously, then you're good. Now we move on to the last denominator. So x minus 4 different from 0, x plus 3 different from 0. So 4 conditions. So here you get that x minus 2 different from 0 implies that x different from 2. X plus 2 different from 0 implies that x different from negative 2. X minus 4 different from 0 implies that x different from 4. X plus 3 different from 0 implies that x different from negative 3. Now you can make cancellations. So x plus 3 cancel out. Then x minus 2 cancel out. And you're left with the numerator is just x minus 2. The denominator include x plus 2 times x minus 4. Good. Any questions? All right, let's move on to the next example. Again, you have two rational expressions multiplied together. First, factor the numerator and denominator when possible. So the x squared minus 2x plus 1 give me x minus 1 times x minus 1 over x times x squared plus 1. So in the denominator of the first rational expression, yeah, x as a common factor. You take out the x and you're left with x squared plus 1. Multiply with the second rational expressions. On the numerator, 4 is a common factor. And the denominator can be factored into x plus 2 times x minus 1. Next step, condition. We have two denominators. So here, 1, x different from 0. Okay. Then x squared plus 1 different from 0, but x squared plus 1 is always positive. You with me on that? Right, so you don't need to impose the condition of x squared plus 1. You follow? Okay. And then x plus 1 different from 0. Sorry, x plus 2 different from 0, and x minus 1. This is 2, just to be clear. So x different from 0, x plus 2 different from 0 implies that x different from negative 2, and x minus 1 different from 0 implies that x different from 1. Then cancellations. So x minus 1 cancel out. Then x squared plus 1 cancel out. And you're left with 4 times x minus 1 divided by x times x plus 2. So in the next two example, can you do it yourself or you can talk with your friends if you want to? I'm gonna give you like 15, 30 seconds and we're going to walk around and look at your work, okay? Hold on 1 second. So try to factor the numerator and the denominator when possible. So I have x plus 4 times x plus 3 divided by x minus 4, x minus 3, all together divided by x plus 4 times x minus 3 over x minus 4 times x plus 3. So far, so good, yeah? So this is what everyone got. So you divide a fraction, that means you can multiply by the reciprocal. So x plus 4 times x plus 3 over x minus 4 times x minus 3 times x minus 4 over x plus 3 divided by x plus 4 times x minus 3. Okay. Any questions? Conditions. Next step is conditions. So here for x minus 4 and x minus 3, you do x minus 4 different from 0 implies that x different from 4. X minus 3 different from 0. X is different from 3. This condition, x minus 4 different from 0, we already got that, so we can ignore it. X plus 3 is different from 0. So you get x different from -3. Then move on to the last denominator here. X plus 4 is different from 0. X minus 3 is different from 0. But we already got x minus 3 different from 0, so we good. Okay. Now, next step, cancellations. X plus 4 cancel out. X minus 4 cancel out. And we left with x plus 3 times x plus 3 on the numerator divided by x minus 3 times x minus 3. Right. Then for short, combine the two terms together. This is what you get. Any questions on C? Good. Now for D, again, you factor the numerator and the denominator when possible. So this is what I got, x minus 5 times x plus 2 over x plus 7 times x minus 5. That's for the first rational expressions. The second rational expressions give me x plus 7 times x minus 3 over x plus 7 times x plus 2. Now conditions. So x plus 7 different from 0 implies x different from -7. X minus 5 different from 0 implies that x different from 5. Then x plus 7 different from 0, but we got that already. So we good. Then one more conditions, x plus 2 different from 0 implies that x different from -2. Next step is cancellation. So x plus 7 cancel out. Right. For this one, you can cancel this x plus 7 with this x plus 7, or this x plus 7 with this x plus 7. You follow the idea, got it? It's the same thing. Now x minus 5 cancel out. And one more x plus 2 cancel out. And you're left with x minus 3 over x plus 7. Good? All right. What time do we go? 1:20. Plenty of time. Any questions? Any questions? Do you want to show something? All right, so we're gonna move on to the next topic, which is addition and subtraction between two rational expressions. Again, the procedure you see on the board is just for me to show you steps that you can follow. But if you already know what to do, just follow the steps. Okay. So the first step for addition and subtraction is that just factor the numerator and the denominator when possible. The second step is to look at the denominator and find the least common multiple of the denominator, or the least common denominator, CT. Now you make each denominator in don't even understand what makes each denominator in the expression. In each expression, the same as the LC. All right, so let's fix that. So make each denominator in each expressions the same as the LCM. Then the next step is to add and subtract the numerators, but leave the denominator the same. So you manipulate the denominator in the second and third step. And the fourth step, you just leave the denominator the same, but add or subtract the numerators together. And then the last step is to simplify the numerator when possible. All right, so let's take a look at the following examples. So you have two rational expressions added together. First step is to factor the numerators and the denominators when possible. So you have x over, so the first expressions, you factor the denominator and it's give you x plus 2 times x plus 1. And for the second expression, you have x plus 1 times x minus 1. Okay, so whatever you see in the denominator, I call them factors, right? So you have the factor x plus 2, the factor x plus 1, the factor x plus 1, factor x minus 1. So that's the terminology that I'm going to use. Okay, now how would you find the LCD? So for each denominator, you're gonna take the factor and put into the LCD. Okay, so bear with me here. So for the LCD, this is equal to, so look at the first denominator. You take out the factor x plus 2, put that in here. X plus 1 put into the LCD. Okay. Now you're done with the first expressions. Right. You move on to the second expressions. X plus 1, the factor X plus 1, you already got it. So ignore it. You with me? Then the next factor X minus 1, related to LCD. And that is your LCD. You follow? Okay. In the next example, we get the factor square that we will, it's going to be a little bit different, but for now, we understand the process. Okay. So that's the LCD, that's the second step. Now the first step is to make each denominator the same with the LCD. You're okay. So for the first expression, you have x plus 2 times x plus 1. What is missing from the denominator? X minus 1, right? So you're going to do, you multiply the top and bottom by x minus 1. For the second expressions, you have x plus 1 times x minus 1. What is missing? X plus 2. What you do is you multiply and divide, or you multiply the top and bottom by x plus 2. You with me? All right, so that's the next step. Right, so what I'm doing is, so x over x plus 2 times x plus 1. And we agree that we are missing the term x minus 1. So I'm going to multiply the top and bottom by x minus 1. So that's just the first expressions. The second expressions, again, we agree that we are missing the term x plus 2. So I'm going to multiply the top and bottom by x plus 2. We okay? We understand where everything coming. Good. All right. So now the denominators are the same. So we keep the denominator, we combine the numerators together. So we have one denominator, which is x plus 2 times x plus 1 times x minus 1. We have the same denominator. We're just going to combine the numerators together. So the first numerator is x times x minus 1 plus the second numerator, that is x times x plus 2. Questions? Concerns? All right. So now the last step is to simplify the numerator as much as you can. Okay. So to do that, what I do is I just do x into parentheses, this x into parentheses. See what you get. The denominator is the same, right? The denominator, don't touch the denominator at this point. So x plus 2 times x plus 1 times x minus 1. You get x squared minus x plus x squared plus 2x. Then you combine like terms. So x squared plus x squared become 2x squared. Minus x plus x, you get plus x. And the denominator is the same. Yeah. Define it. So x is the common factor now. So you do x times 2x plus 1 all together divided by x plus 2 times x plus 1 times x minus 1. Good. Here. Am I missing anything? Miss something very important. There you go. Got to put down the conditions for the rational expressions. Okay, so let's do that. So I'm going to do that up here. So there are 4 different terms. So x plus 2 different from 0, x plus 1 different from 0, x plus 1 different from 0. Okay, we got that really good. X minus 1 different from 0. So here, x plus 2 different from 0 implies that x different from -2. X plus 1 different from 0 implies that x different from -1. And x minus 1 different from 0 implies that x different from 1. Yesterday toward the end of class, we start talking about addition and subtractions of rational expressions. Okay. So we follow certain procedure. Again, I want to mention that if you already have your procedure to work for you, then just follow that. Again, all this step are here because I assume that all of you have not seen this before. But let me go through the step one more time. First thing first, when you're given a problem, add 2 rational expression added together or subtracted one another, try to factor the numerator and denominator when possible. And then the next 2 step is to find the LCD, the least common denominator, and then try to make each denominator the same as the LCD. And then after the next 2 steps, you have the same denominator, right? So you keep the denominator and combine the numerators together, and then simplify the numerators as much as you can. Okay. Any questions on that? All right, good. So let me go through one more example, and then I will pass the problem back to you for your practice. So in this problem, again, you have 2 rational expressions, one subtract the other. So 2 over x squared minus 7x plus 6 minus x over x squared minus 2x plus 1. So again, we're going to factor the numerator and the denominator when possible. But in this case, there's nothing to factor on the numerator. So here's what we do. So we factor the numerator. So x squared minus 7x plus 6 will give me x minus 6 times x minus 1 minus x over x minus 1 times x minus 1. Any questions on this factor? All right. So in the second expressions, you see in the denominator, you have x minus 1 times x minus 1. So I'm going to rewrite this denominator as x minus 1 squared. You okay with that? Okay. So 2 over x minus 6 times x minus 1 minus x over x minus 1 altogether square. Now you find the LCD. Right? So what we did, we look at factor in each denominator. So for the first denominator, you have factor x minus 6. Okay. And then x minus 1 to put into the LCD. So here, x minus 6, x minus 1. We're done with the first expressions. We move on to the second expressions. You have x minus 1 as factor. We already get here. But in this case, you have x minus 1 squared. Okay. Choose the highest power between the two factors here, x minus 1 and x minus 1 squared. You choose the square. You okay with that? So now the LCD is x minus 6 times x minus 1 squared. You okay with that approach? Any questions? Okay. So you got the LCD. Now the next step is to make the denominator same with the LCD. So x minus 6, x minus 1, what is missing from this denominator? Another x minus 1, right? So you multiply top and bottom by x minus 1 for the first rational expressions. What is missing in the second term, or the second expressions? X minus 6. So you multiply the top and bottom by x minus 6. Okay. So here's what we do. You got 2 times x minus 6 times x minus 1. We are missing 1 x minus 1. So you multiply the top and bottom by x minus 1. For the second expressions, you are missing x minus 6. So you multiply the top and bottom by x minus 6. All right. So now the denominator is the same. You just combine the numerators together. So you have x minus 6 times x minus 1 squared. And the numerator is 2 times x minus 1 minus x times x minus 6. So now next step is to simplify the numerators as much as you can. Any questions? Okay, so here's what we do. You distribute the 2, so you get 2x minus 2. Then for the second term, you have negative x times x minus 6. So negative x times x, you get negative x squared. Then negative x times negative 6, you get positive 6x. So here minus x squared plus 6x over x minus 6 times x minus 1 squared. All right, so you combine like terms and rewrite the numerators as negative 6x squared plus 8x minus 2 over x minus 6 times x minus 1 squared. And that's how you do it. Good. Any questions?
Why would we cancel with the x minus 6 and the numerator and the denominator?
So you mean like x minus 6 right here? Okay, so we cannot do that because there's subtraction between. Okay. In the previous example, if you go back, when you make a cancellation on top and bottom, there's surrounded by multiplication. So if there's multiplications right here, that Good. All right, so we have two more example. I'd like you to do that, spend a little bit of time on that. We're gonna walk around in about 30 seconds. Okay, yeah. Audrey, you have a question?
For that one, there's software, we can do
Oh, yeah. Okay. I forgot. My bad. Conditions. So, oops. All right. So the conditions, I forgot about that, sorry. So the conditions, so x minus 6 different from 0, x minus 1 different from 0, so just two conditions. Okay, good. So for C, again, we try to factor the numerator and the denominator when possible. So you get 3 over x times x plus 1. Right, so x squared plus x, you have a common factor, which is x in this case, so that's how you factor the denominator. Any questions on that? Good. Now for the second expressions, you have x over x plus 1 times x plus 1. Now what I do next is I rewrite the second denominator as x plus 1 squared. So here I get 3 over x times x plus 1 minus x over x plus 1 square. Okay. Yes.
Where'd the plus 4 go?
Oh, sorry. Yes, plus 4 here, plus 4 here. Thank you. All right, so the LCD. So again, how would you find the LCD? So this is two different terms, right? Two different expressions. Take a look at the first one. You have x, bring that to the LCD. You have x plus 1, put that into the LCD. So far, so good. Now we're done with the first term. We move on to the second term. Now in the second term, the factor is x plus 1 square. Right. We already have x plus 1. We just need to put the square to complete the LCD. We cool? All right. Now for the first term, again, you have x times x plus 1 in the denominator. We are missing 1 x plus 1. So I'm going to multiply top and bottom by x plus 1. For the second expressions, I'm missing x in the denominator. So I multiply the top and bottom by x. You okay with that? All right. So here I get 3 over x times x plus 1 multiply with x plus 1 divided by x plus 1 minus x plus 4 over x plus 1 square multiply with x over x. Okay. Now you have the same denominator, just combine the numerators together. So x plus 1 square times x. Right, the numerator is 3 times x plus 1 minus x times x plus 4. Simplify the numerator as much as you can. So The numerator is 3x plus 3 minus x squared minus 4x. And the denominator is x plus 1 squared times x. And finally, you get negative x squared minus x plus 3 over x plus 1 squared times x. Any questions? Now we're going to do the conditions. Okay. So the condition is that x different from 0 and x plus 1 different from 0. Good. Questions? So x different from 0 and x plus 1 different from 0 implies that x different from negative 1. Any questions on problem C? Now for problem D, we're going to do the same thing. Let's factor the numerator and the denominator. So 4x over x minus 2 times x plus 2 minus 2 over x plus 3 times x minus 2. So LCD x minus 2, x plus 2, put that into the LCD. All right. So we're done with the first term. We move on to the second. All right, so you have x plus 3, put that into the LCD, and then x minus 2, but we already got x minus 2. So that is our LCD. Cool. All right. So now for the first expression, it's missing x plus 3. I'm going to multiply the top and bottom by x plus 3. For the second expressions, we are missing x plus 2. So I'm going to multiply the top and bottom by x plus 2. So you have 4x over x minus 2 times x plus 2. Multiply the top and bottom by x plus 3. That's the first term. The second term is 2 over x plus 3 times x minus 2 times x plus 2 over x plus 2. Now you have the same denominator, just combine the numerators together. So x minus 2, x plus 2, x plus 3. The numerator is 4x times x plus 3 minus 2 times x plus 2. Okay, simplify the numerators. I get 4x squared plus 12x minus 2x minus 4 over x minus 2 times x plus 2 times x plus 3. Now you combine like terms. You get 4x squared plus 10x minus 4 divided by x minus 2 times x plus 2 times x plus 3. So the numerator, you can take one more step. That is, the 2 is the common factor. Right? So you do 2 times 2x squared plus 5x minus 2 over x minus 2 times x plus 2 times x plus 3. So that is the final answer, but we're going to put in the conditions. But any questions up to this point? Now the conditions. So I have x minus 2 different from 0, implying that x different from 2. x plus 2 different from 0, implying that x different from -2. And x plus 3 different from 0, implying that x is different from -3. Good. All right. So that's it. We finished with lecture 3. So in this lecture, we look at rational expressions. So rational expression, again, is a divisions of polynomial expressions. Okay. With rational expressions, you can multiply them together, divide with one another, add them together, or subtract one another. You okay with that? Okay. So let me stop right here on lecture 3. We will have the first quiz on Monday of next week. Okay. And the quiz will be on lecture 3. Okay. All right. So there will be 2 questions on the quiz. One question is rational expression multiplied or divided by one another. And the second question is 2 rational expression added or subtracted one another. We good with that? Okay. I will send an email or announcement on that later on this week. Okay, so we're gonna move on to the next lecture, which I think you got the lecture notes already. It's about distant and midpoint formula.